previous video, we talked about the characteristics of the variables and why we may need to engineer them before we use them in machine learning models. In this video, I would like to give an overview on the specific techniques that we can use to tackle each one of the problems we discussed. We talked about data quality and data format, and we mentioned that data can present missing data or categories, or data may be in different scales, or may have distributions that are not suitable or present outliers. And for all of these, we want to perform transformations. We also mentioned that data can be text, or images, or transactions, or time series, or distance, or variables of date and time, and we would like to extract or create new features from this data that we can feed into our models. In order to do all of this, there are specific techniques that we can use. For missing data imputation, we can perform a variety of techniques. Like, for example, we can replace missing values with the mean or the median, or with an arbitrary value. If the variable is categorical, we can replace missing value by the most frequent category, or by a category that is actually called missing. We can add a missing indicator, or we can perform more sophisticated imputations like end-of-tail imputation or random sample imputation, among other things. For categorical encoding, there are also a variety of techniques that we can use, and just to mention a few of them, one-hot encoding is perhaps the one that you're familiar with, but we can also replace the labels by the count or the frequency of the category, or we can replace them by numbers arbitrarily or ordered according to the mean of the target. We can also perform mean encoding or replace the labels by the weight of evidence, and we can perform more sophisticated techniques like binary encoding and feature hashing. When we have rare labels, so a lot of labels that appear only in a few observations, we tend to group them into one umbrella term that we can call rare or other, or any term that we like. To transform variable distributions, we can take two approaches. The first one is to apply mathematical transformations to try and obtain a more Gaussian-like distribution of the variable, and usual transformations are the logarithmic, the exponential, the reciprocal, the Box-Cox, or the Yeo-Jonsson. Or alternatively, we can discretize our variable. This is, sort the continuous values of the variable into discrete intervals. And there are also a variety of discretization techniques like equal width or equal frequency, or clustering, or replace the values by the predictions of a decision tree. If we want to remove outliers, we can either perform discretization, which will allocate the outliers to the end intervals of the distribution, or we can censor the outliers, or we can straight away remove them from the dataset. When we want to put the variables in a similar scale, there are also a number of procedures that we can apply, and the most common ones are standardization, where we subtract the mean value and divide by the standard deviation, or the scaling to the maximum and minimum value. If we have date-time variables, we normally don't use them in the raw format to train our machine learning models. We instead extract a lot of information from them, like the day, the month, the semester, the year, the hour, minute, and second, the time between two data variables, and like this we can extract features like, for example, the time between transactions, or the age with the date of birth at the time of the transaction. If we have text, we can also extract values, like we can count characters, words, unique words, and with this we can construct the lexical diversity. We can count sentences, paragraphs, we can create bag of words, and we can also create term frequency, inverse document frequency features. When we have transaction time or time series, what we can do is aggregate the data to obtain a single point of view for the customer. For example, if we have historical data for some customers, we can aggregate them so that we now create features like the number of payments in the last 3, 6, or 12 months, or the time since the last transaction, or the total spending in the last month, and so on. With geodata, we can calculate distances, for example. And finally, we can combine many of the features that we have in our dataset with simple combinations like the ratio between two variables, like the example here is the total debt with the income. We combine it to create the debt to income ratio, or we can sum the debt in different, for example, credit cards to obtain the total debt, or we can subtract one variable from the other to obtain, for example, disposable income. So as you can see, there are a lot of transformations that we can do to the data before we use it in the machine learning model. We will be performing many of these transformations in the machine learning pipeline that we build in a couple of videos from now. That is all for this video. In the next one, we will discuss feature selection.